All right, let's tackle number 5 on the parallel series circuit worksheet. We observe this parallel circuit here where we have 3 different branches, each branch with 1 resistor. We're asked to use the laws of circuit theory to solve for the total resistance, the total current, as well as the current through each resistor or each branch, and the voltage through each resistor. Okay. Well, the first thing that we can do is we can calculate the total resistance. And we really want to have that. If we can have the total resistance of this circuit, then we can use Ohm's law. We've got our total volts already provided. We'll have the total resistance, and then we can find the total current. And we can find this because they've given us each of the resistor values. So for a parallel circuit, the formula for the total resistance is 1 divided by the sum of the reciprocals of each resistor. So basically the reciprocal of resistor 1 plus the reciprocal of resistor 2 plus the reciprocal of resistor 3. So our values plugged in, and we'll just end up plugging this on our calculator and getting an answer. We've got 1 over 450 plus 1 over 390 plus 1 over 620. So let's plug that in and see what we get. Well, to plug that in, we'll first find the sum of the denominator. 1 divided by 450. On a graphing calculator, I put the fraction in parentheses, just using division, so 1 over 450, 1 divided by 450 in parentheses, plus then 1 divided by 390, plus, in parentheses, 1 divided by 620. And that's going to give me the denominator. But the total resistance is really 1 divided by that value. Now I can type all that in, or I can use the second answer. It'll copy the previous answer. So I got a total resistance of 156 point, we'll round, how about the 3 decimal places right now, 269. So 156.269, this is resistance, so ohms. Let's fill that in. Over here, 156.269 ohms. Now that we have the total resistance and we already have the total volts, we can go ahead and use Ohm's law. The total volts equals the total current times the total resistance. Thinking about what I'm writing. Thinking about resistance now. When I put an R there, it should be total. Okay, so the total volts was 12. The total current we don't know. That's what we're going to find. And the total resistance was our 156.269. To get the current alone, we need to divide both sides of our equation by 156.269. So let's do 12 divided by, again, I'll just do my answer on my calculator. So I won't even have rounded yet. And this becomes 0.07, let's see, it's 679. So maybe I'll take it out, just 3 decimal places, so we'll just go ahead and round that up to a 7. So my total volts was 12 volts. My total current is now 0.077, and that's amps. Okay. Now, we want to find the volts at R1, R2, R3. Well, here's the good news. In this problem, since we have a parallel circuit, voltage is pressure. Imagine that we've got pressure through these lines, and pressure will equalize in all these spaces. The pressure remains constant in all branches or going into each resistor. So this 12 volts doesn't change. Even though we're branching it off, we don't have any resistor that has that the electricity has gone through that's going to decrease our voltage. So in this type of circuit, a parallel circuit, you have the full 12 volts of pressure going into each branch. or in that case, at each resistor. So 12 volts, 12 volts, 12 volts. That was easy. All right. The current, however, we know that we've got this total current of 0.077 amps, but once it gets to here, it can split off. Some of that electricity can come this way, some of it can continue on this way. For what comes this way, that can branch off. So where you need to go through and calculate how much electricity, how much current actually flows through each branch. To do that, we're going to use Ohm's law again, V equals IR. But instead of using the total values, we're going to use basically each branch, or R1. Okay, so the voltage we know going into the first branch is the full voltage of 12. The current we don't know because it's going to branch off. So we're going to leave that as our unknown. But we do know the resistor was 450 ohms. So now divide both sides by 450. And you get 0.026 repeating. So that would be about around 67. And that's amps. 0.0267 amps. Now, to get the current at R2 and the current at R3, we would repeat this exact same process. The only thing that's going to change, our voltage won't change, our current is still the unknown, but the resistor. So we're going to take this 12 each time and divide it by the different resistors. So let's just do that more quickly here. The current at R2 is going to be 12 divided by that resistor, 390. And the current at R3 is going to be our 12 volts divided by the 620 ohms. So let's get those real quick. 12 divided by 390 is 0.0308. 0.0308 amps. And for this one, 12 divided by 620 is 0.01935. So I'm going to round to the same number of place values 4. So that 35 will round to a 4 there. 0.0194 amps. Now Kirchoff has a current law, Kirchoff's current law, and that is for parallel circuits. It says that the total current is equal to the current through branch 1 plus the current, what we say, resistor 1, resistor 2, and the current through resistor 3, and so forth. So we can confirm Kirchoff's current law by now adding up these currents and seeing what we get. We should get the total current, which was our 0.077. So to confirm this, it's really a question of does 0.077, does that, question mark, will that equal our 0.0267 plus our 0.0308 plus our 0.0194. And if I type those back up on my calculator real quick, 0.0267 plus 0.0308 plus 0.0194, I get 0.0769, which is really, really close to 0.077. Remember, I rounded. So yes, Kirchoff's law has been confirmed. We'll just put an arrow there.